Alright, here we're going to take a look at another question that has an application of the chain rule. So if v of s is equal to s cubed and s is equal to 3x squared minus 7x plus 1, determine dv with respect to dx, right? The derivative of dv with respect to dx when x is equal to 3. Okay, so when we're looking at this question, we need to understand that in the case of the chain rule, v of s is equal to s cubed. So the derivative of v of s, which is v prime of s, you can think about this as the derivative of d with respect to ds. Okay, so it's like dv with respect to ds, which is basically the derivative of s cubed. Okay, so this is the derivative of v with respect to the rate of change of ds. Now, if we're looking at the other function, this is basically s of x, because s is a function of x. We get 3x squared minus 7x plus 1. If we find a derivative of s of x, we're basically finding ds with respect to dx, right? So this is the first derivative of s of x, s prime of x, and we can basically calculate each of these, right? So it's basically the derivative with respect to dx of 3x squared minus 7x plus 1. Now we want to figure out dv, the rate of change of v with respect to the rate of change of x, right? So dv with respect to dx. In order to do this, we need to basically multiply the derivative of v with respect to s by the derivative of s with respect to x. And you can notice here that these two would cancel out and you would actually get dv over dx. So dv over dx is going to be equal to the derivative of dv over ds, which is the derivative of s cubed, and would multiply this with the derivative with respect to x of 3x squared minus 7x plus 1. Okay, so when we're doing this, we're basically going to find the derivative of each with respect to each of the variables. So we have s cubed, the derivative with respect to ds, so we get 3s squared times the derivative of this polynomial. We're going to be using the combination of the sum and difference rule. So we'll get 6x minus 7. Okay, so this is dv over dx. And in this case, what's going to happen here is we want to figure out dv, oops, I wrote y instead of v, sorry. So we want to figure out dv, the rate of change of v with respect to x, when x is equal to 3. Okay, so in order to do that, we need to kind of get rid of this s variable. So we can notice here that s is equal to 3x squared minus 7x plus 1. Now you could do this one of two ways. You can either just plug this in, or what you could do is you could plug in s of 3 into s, right? So think about this as s of x. S of 3, which is equal to 3 times 3 squared minus 7 times 3 plus 1, which is equal to 27 minus 21 plus 1, which is basically 7. So s of 3 is equal to 7. Well, we can actually plug in this value into s. Okay, so because we're going to eventually plug in s in terms of x either way, it's just going to be the same thing. So this is 3 times 7 squared times, now I'm going to plug in, everywhere I see x, I'm going to plug in 6. So you get 6 times 3 minus 7. So this is going to basically be dv over dx when x is equal to 3 is equal to 49 times 3 times 18 minus 7, which is 11. And if I punch all this out, you should get 1617. Okay, so therefore dv over dx when x is equal to 3 is equal to 1617. Okay, and that's the rate of change when x is equal to 3.